Hello everybody, welcome to my channel. Today we have a very good problem for you guys. I'm going to be talking about find all anagrams in a string. So this is a very good one, so make sure you pay close attention to the problem statement, right? So he says given two strings, S and P, right? Return an array of all the start indices of P's anagrams in S, right? You may return the answer in any order. So pretty good problem statement, right? So two strings, right? And we need to return the start indices of the uh, of anagrams of P's anagram in S, right? Okay, so what they're saying is that we need to find if there exists A, B, C, right? Inside of of S, right? And for each of those substrings, right, that we end up finding a permutation of those characters, right? Then we go ahead and start, right? So for example, right, they said we need to find A, B, C, right? And since we're looking for not only that particular string, right, we want the permutation, right, which is a different arrangement of the letters of ABC, right? It could be BAC or CAB, right? So different rearrangement of the letters, right? So that also counts as finding the string, right? Right? Because that's what they're saying, right? So CBA is a different arrangement of ABC, right? So we found that. That's why we end up putting 0 here, right? And then index 6 as well, they were able to find 4, 5, 6. We were able to find one here as well. And that's why we put the start indices of that particular item, right? The start indices are 6, right? Okay. Also, that's why that's kind of the whole gist of it, right? So for example, for this one, it's a little bit more simple. So we need a different arrangement, right? Okay, we found one here. At 0, we find another one here. At index 1, right? Because that's when it started, right? Also, we end up finding one here, right? So we see a bunch of examples where that's the case, right? So for pretty simple problems there, right? So pretty much just telling us to find the start indices of all the different substrings, right? Where we may find an anagram of P inside of S, right? Okay. So it's kind of the whole gist of it, right? So how can we go ahead and solve this particular problem, guys, right? So um yeah, so what I'm thinking is, right, for this particular problem, we can have we can start with brute force method, which is just we generate all possible permutations of P, right? So we would start, we would do things like ABC, then we would do ACB, then right, then BAC, right? We keep doing every possible different arrangement that the letters can be, right, for this particular one, right? So yeah, and then once we have that, right, we generate all possible, right? Right? Then we would essentially, right, go ahead and through the string, right? As we look through the string, we go ahead and we can see for every substring of this particular length, right, of P's length, check do we have a does it equal to any of our permutation that were generated of P, right? If we do have that, right, then we go ahead and add that to our result, right? We said that's one answer right there, right? But yeah, this could really work, right? But it's not gonna be very efficient, guys, right? Because for this particular for P, right, to generate all possible permutation, that will be n factorial, guys, right? Right? This is actually a legal problem. Like, dude, this is a very, very slow thing, right? Because you try all different rearrangements, right? Which is not very efficient, right? Okay, so we need to be a little more clever, right? So what we ended up doing last time, which is the easier problem of this problem, easier version of this problem, because we did before, right? And the trick that we ended up doing, right? Okay, we what do we really care about here, right? Okay, we care about finding a substring, right? Okay, so we can easily tell if a substring is a different rearrangement of ABC, right? Of this piece, right? By creating some sort of something that's called a frequency map, right? Right? So if I have two strings, right, of the same length, right, and their frequency map, right, are the same, then I can confidently say that it is an anagram, right, which is just a different rearrangement of the characters of P, right? So for example, right, to really drive the point home here, right, we have, for example, right, say we create for P, we create a frequency map, right, which is the frequency of the characters, right, of P, right? So we have one A, right? We have one B, and we have one C, right? So simple as that here, right? So we created that. So we end up creating that, right? Which is, doesn't take that much time to create it. Okay, just so it's linear loop. And then now, right? If we have another string, right? Let's say we have called X, right? And X is equal to BAC, right? Uh we create the frequency map, which is we have one, so we have one B, we have one A, right? And we have one C, right? And it is equal. So to just make it very, very clear, right? I'll just move the A up there, right? So the frequency map, right, equals this one, right? Okay. So we can confidently say that, this is an anagram of that one because we have the exact same characters at the exact same frequency, right? So pretty much you could compare this string to this string. It's literally the same, right? So that's kind of how we're gonna do it, right? Okay. So you might say, how is it gonna be helpful here in this long string, right? It's not too convenient, right? Okay. So now that I've sold you on the idea of frequency map, right? We can compare two strings, right? And easily tell if they're anagrams, right, of each other by just checking the frequency map of that particular string, right? We're gonna use that idea, right, to for longer strings, right, what we're gonna do, we're gonna use the idea of the sliding window technique, right? And the reason why we're gonna use it, right, is because the sliding window allows us to keep track of a particular like like whatever substring that we're referencing, right, in our current window. We can easily keep track of the frequency map, right? And as we leave characters behind and we expand forward, right? So let's say we start with this one, right? And then we need to check the next set of three characters, right? Which is this one, right? Instead of recomputing it every time, right? Which wouldn't be efficient, right? We simply subtract the frequencies, right, of the character that we're leaving behind with and then add the new character that we're adding up here, right? So this example would be, so let's say we have P here, right? This is our target string that we want, right? And then the target frequency map, right? So we would loop through, right? We would create similarly the same thing, right? So for this first, so we have one C, right? And then we would, because we know the sliding window is going to be a static sliding window, pretty much, right? A static one of the length of P, right? Because that's the target string that we want to see, right? So for every three substring, right, we check, right? So essentially we start with C, we have one C, we have one B, and we have one A, right? So that's the first one, right? So we have a left and right pointer, right? So that's the first string that we look at. And we see that this frequency map equals the P's length, right? So we add that to our result, right, which is 0, right? And then now that we're moving forward, right? We remove, we need to leave C behind so we can add E, right? Because we're checking three at a time, right? It's a static window. So we shrink with the left pointer and then we expand with the right? Okay. So we remove C. We have one less C to worry about because that's the thing that we're considering now, right? And then we add a E. E is equal to 1 now, right? And this is how the map looks like now, and it's obviously not equal to that one, right? Okay. Right. So you see how at whatever given time, right, we can know exactly the characters that we have in our window, right, in the frequency of those characters, right? So that's how it allows us to efficiently, right? And then we check, right? Does this frequency value go to this one? No, it does not, right? So we go ahead and move forward, right? We move to this one now, right? We have one less beat to worry about. Okay, so this one, and then now, and we also, since this is a B, we add a B to it, right? Which is one. Still does not equal to this one, right? So now the next set is this one, E, B, A, right? So we remove the A, and then we re-add it again because of this A right there, right? Okay. Because this A right there, right? Okay. So now we were here, right? So now what we're gonna do, we move forward. Does not equal to the. You can do this one, right? So there's no more E, right? Because we leave this E behind, right? And then now the current thing is this one. Okay. So now we remove this one. We have two, right? We have two B's. Does not equal to this one. Nope. Right. So now we move forward. We have this one. We have one less B to worry about. So now we decrement it, right? So now it's this one. Now we have two A's in our current window, right? We check again. Same, still not the same. And then we're here. And then now what we're gonna do is this one, BAC, right? So we have one less A, and then we're adding this C, right? And that's how we're able to say, all right, cool. Does this one equals to this one? Yes, it does, right? And then we go ahead and put the start and this index of that particular one, right? Which is 6 here, right? So that's kind of how it works, guys, by easily comparing, right? You know, the comparisons are, you know, the map is of size 26, right? So it's not it's constant here. Okay, so we don't talk about the comparison. It's very fast. Okay, so looks like we do understand the logic, right? Let's go in the code. I think the code would be a lot more intuitive, a lot better for you guys, right? Let me know if I really explain it well or not. Okay. Yeah, the code will be very, very simple, guys. So let's quickly go ahead and do that. So what we're gonna do is we said that we're going to have a map, right? So we'll be using a frequency map and right an array to represent the frequencies of the characters, right? You know, so it would be of size 26, right, to represent the 26 characters of the alphabet, right? You know, so index 0 would be A, index 1 would be B, so on and so forth, right? You know, so we capture the frequencies of P, right? So we created two maps, right? Okay, so this one will help us to build our frequency map as we go, right? In our sliding window over S, right? The longer string, right? And we increment, decrement as we go along, right? And then we have P, right? Which is, you know, to help us to easily get the target frequency map that we want, right? Because we want to get a match. Every time we get a match, a substring in S, right, that a window, right, that has the same frequency map as P, then it tells us this is just a different arrangement of the letters, and it's the anagram of that. So that's a answer that we want, right? Then we also want to capture pretty much the output result, right, which is will contain the result that we need. Okay. Okay. Now, okay. So now what we're gonna do is to loop through the string, which is the P string, right? So to build our P frequency map, right? Okay. So it do P that to char array. Okay. So yeah. So now that we have that, right, guys, right? The next thing for us to do now is to just do some ASCII value subtraction, right, to get the red index, right, for that particular character, right? So if this character is A, right, then it'll be A minus A ASCII value, right, equals 0. Then just put in 0, right? If it's B, then it's 1 higher than A, right? So that's how we get index 1, right? Okay. So we end up incrementing it, right? So this should be, this is the wrong frequency map. It should be frequency P, right, to keep track of the characters in P, right? So yeah. So now that we have that, right, now we've populated, right? So the map would be index 0 is equal to 1, index 1 equal to 1, right? To represent that there's 1A, 1B, and 1C, right? To make it clear for you guys, okay? So now we're going to start our sliding window, right? And left equal to 0, okay? And then we have our loop, right? And let's call it right, go to 0. It is less than s dot length, right? Because that's the string that we're looping on. right plus plus. Okay. Yeah. Okay, now that we have that, is to now just start adding stuff to our window, right? And yeah, I think that's what's left now. Chain right is go to s at char at the right pointer. We capture that thing, right? And since we're using this one, right? Frequency, right? Frequency s, right? Char right minus ASCII value, right? So we increment the count of that character, right? Because then we're adding this thing to this character in our window, right? And yeah, so initially everything's 0, right? And then now we encounter the first character, right? So now we increment C, right? And so index 2 is equal to 1, right? And everything else is 0. Pretty much you can think of it, right? Okay, so we keep doing that, right? And then if, right, we do a comparison, right? If arrays that compare, right? Got some neat function here, right? Compare those two those two arrays, right? Pretty much frequency of S and frequency of P, right? Remember what they represent, right? So frequency of S represent the frequency of the characters in our current window with the frequency of P, which we populated at the beginning, right? So we compare those two here, right? If that's the case, then we go ahead and put these index, right? Which index we put? We put the left pointer because in our whatever window that we have, right? The start index is the starting index is always the left pointer, right? Because you know that's what the left boundary and the right boundary, right? You know, so for our current window here, left would be pointing at C, right? So we can easily put the 0 here, right? Okay. So now that we have that, right, we can also check here, right? And so we need to know when to shrink, right? Because we keep adding, right? We need to know when to shrink, leave characters behind, and move forward, right? So the length stays consistent at P's length, right? Which is 3 characters. Okay. So now, if right minus left plus 1, right, is greater than or equal to P that length, right? Then this is where we need to start thinking about moving, right? Char left is that char left, right? We have our left pointer. Okay. So this character, we need to start thinking about removing it, right? Because we're not accounting for this anymore, right? So we need to remove the frequency here, right? The count. Because I have one less of that character, right? Exactly like I was doing earlier, guys, right? So this is how we're able to maintain, right, our frequency, right? And at any given point, we can tell, right? Because we're simply adding and removing, right? We don't need to recompute every time the frequency amount of that substring, right? Okay, so we could easily, that's what a sliding window is for, right? If it wasn't for the sliding window, then for each substring, right, we would need to recalculate thing over and over, right? Because let's say the substring was like 10 characters long or a million characters long, right? We would need to loop every time. But with this one, we don't need to loop every time because everything in between stays the same, right? We just add characters and remove characters at the beginning, right? And that's how we're able to maintain that just two operations. We can easily tell at any given point the amount of the frequency of characters in that picture string, right? And then using that information to just do a easy comparison, right, of just two frequency maps, right? Okay. So now after we remove that character, we simply move up this character, move up, right? This pointer, right? Because we can't leave it behind. Okay. Looks good to me. Let's press. Let's just return the result, right? I think we should be in good shape. So yeah, see how the code looks. So let me know if it makes sense to you guys. So we have a frequency map, S and P, right? And then we build our P frequency, right? So that we can use it to compare, right? And then we add stuff to our window. As we're adding, we also count, we have 1 plus of this character, right? Keep adding, and at a given point, we end up having a match, right? Then we go ahead and do that, right? So let's press 1 because we express these small test cases. Okay, so it should be close to 0 because it returns an integer. Okay, that's good. Let's press submit. Awesome, guys. Looks like we passed all these test cases. If you guys found value, you guys understood the thought process, and do that in the comment section. If you guys are new here, make sure to follow and like the, if you guys found value, make sure to like and subscribe, right? If you have any questions in the comment section as well. And then, yeah, I'll see you guys in the next video.